Hello, everybody. We're going to be talking about hormones, really with the endocrine system just in general. Communication system, really kind of focusing on, we have the nervous system. Endocrine system is more chemical communication. Once again, the nervous system, more electrical communication. Definitely is going to be much slower responding than the nervous system, right? So it's just going to, the nervous system is going to stimulate a lot of the endocrine system. With that, we have multiple sites sometimes, just getting that chemical communication, have to travel through the blood. It just takes a little bit longer. Really, one of the big things with the endocrine system, maintaining homeostasis. We're going to have hormones that are kind of regulating cell organ activity. We're going to have it kind of going to specific cells, these target cells. So sometimes it's going to go to one specific cell, our target cell, and then that responds kind of a chain reaction to release other hormones. So it's kind of, once again, it's kind of a systemic type response where you're going to see kind of multiple different target cells helping to assist with the release of these hormones. Really similar to, I kind of think it's similar to like sweating. Really, with the hormone release, it's kind of more is going to be a slow kind of pulsatile type response to hormone release, and then we're going to see more and more based off the stimulus or based off of the task that we're trying to do. But really kind of most hormones, we're going to respond kind of for a 24-hour cycle where we see kind of, once again, the upregulation of some specific hormones. And then we see that kind of downregulated at certain times of day. We definitely see adrenaline more being released when we kind of first wake up. We're going to see adrenaline, cortisol kind of increasing as soon as we wake up. Or once again, kind of at night, we're going to see the increase in melatonin, right? So we have this 24-hour type cycle. Now, definitely my 24-hour cycle is all messed up being, coming back from Africa. But at the same time, it's once again, it takes a while till you have that. But once again, it should be kind of on a 24-hour cycle. Now, definitely circadian rhythm, once again, 24-hour cycle. Kind of, this is an example of what you can kind of see throughout the day. Now, definitely based off work schedules, based off of how you're sleeping at night, other things, this could be thrown off, but this is kind of on average. If you don't have kind of a night shift, this is what it could look like in regards to hormone release. Now, one thing I would recommend, and this is something that I could be asking about on exam, on a final exam, is kind of I'll ask about kind of this fastest reaction time. Once again, kind of right around 3:30, highest blood pressure right around kind of that 6:30 time. And then I have kind of in this PowerPoint slide, I'm not going to talk through it in this presentation, but I would like you to read through some of these other slides that I have, kind of highlighting when is a good time to actually, for different groups, when is a good time to actually exercise, work out, strength training versus aerobic. I kind of talk through that in kind of multiple slides, so I would like you to kind of read through the different slides on that. Okay. So once again, circadian rhythm, 24-hour cycle, really kind of our biological clock and helping overall with, digestion, absorption, just metabolic activities just in general, and endocrine function. So really with this, it is key, and it is key to have kind of the upregulation, downregulation of different hormones throughout the day. All right. So one of the first kind of hormones and group of hormones I want to talk through is the release from the adrenal medulla. This is going to be the adrenaline, okay, the catecholamine. So this is epinephrine, norepinephrine. And like I said, I'm kind of using adrenaline, catecholamines as somewhat interchangeable. We're talking about the same thing. Or epinephrine, norepinephrine, this is what we're talking about. So there's several different factors that could actually determine kind of the response to exercise and the impacts on exercise, but definitely exercise intensity. If we increase that overall intensity, we're going to have more epinephrine, norepinephrine actually being released. Exercise duration, same thing. Age, gender. So as we get older, definitely we're not going to have as much maybe adrenaline being released, or to the maybe more systemic response. Where gender, same thing. We might have based off kind of specific hormones. Definitely we may not have as much released versus the other. Okay. So some of the things, and really like hormones and the hormone talk, I could spend the whole semester talking about hormones. Really what I'm going to be highlighting here is the impacts that it has on exercise and how this could be helpful during exercise. And once again, kind of key hormones that are responsible for exercise and how it actually helps. So kind of the epinephrine and norepinephrine are going to have different responses to exercise, but with this is the combined effects of epinephrine and norepinephrine. Okay, so definitely seeing a huge increase in heart rate. We're definitely seeing an increase in metabolic rate. So just overall, see that increase in metabolic rate. Definitely in regards to just that. The glycogenolysis of the kind of increase the overall storage of glycogen or creation of glycogen in the liver, breakdown of glycogen in the liver. And the muscle. So once again, we could utilize that and have that released as glucose, and we'd be able to utilize that for ATP production. Release of glucose and fat-free acids into the blood, redistribution of the skeletal muscle. So definitely epinephrine and adrenaline just overall is a vasodilator. So we're going to see that vasodilation in kind of the active tissue. But norepinephrine is actually something where we see vasoconstriction, so helping to kind of shunt that blood to the working tissue. We also is going to help with increase in blood pressure, also increase in respiration. So once again, we can actually, based off of the intensity they want to be at, or based off the stimulus that we have, it's going to help and assist with being able to do that specific task, or once again, run or work at that specific intensity. Cortisol is going to have a similar response that adrenaline does as well. So cortisol, glucocorticoid, is responsible for 95% of the glucocorticoid activity. But similar to adrenaline, we're going to see an increase in a lot of different things here, where it's actually helping to that release of free fatty acids, so we can utilize the fat as energy. It actually decreases glucose utilization, sparing for the brain. So actually within that, we tend to actually work against adrenaline in that regard. Actually helps with breakdown of protein. Okay, actually helps repair enzyme synthesis, so we can still continue to create energy. Inflammatory agent, so actually helps with the anti-inflammatory. Depresses immune reactions. Okay, helps with kind of the overall immune reaction. Vasoconstriction caused by epinephrine. So really within that, like I said, we do see kind of this vasodilation usually by epinephrine. This cortisol will kind of work with norepinephrine to actually have this vasoconstriction, and vasoconstriction in non-working tissue. Okay. Also thyroid gland, once again, we're going to see kind of this upregulation. Really the most important non-steroid hormone is that thyroxine, is that T4, and then T3 as well. It's going to help and assist with kind of upregulation of a lot of different things. This is released from the anterior pituitary gland and then goes to the thyroid gland. Once again, really seeing that dramatic increase in metabolic rate production. So really you see that increase of like 60 to 100%. So once again, you see kind of the protein synthesis helping with the enzymes, so working with cortisol. The size and number of mitochondria in most cells, so actually helping to assist with the increase in mitochondria to help with that ATP production. Rapid cellular uptake of glucose, so it actually takes the glucose up, so we can utilize that as energy. Enhances glycolysis, gluconeogenesis. Okay, so actually helping with the storage of glycolysis, or maybe breakdown of glycolysis to actually help with that. Gluconeogenesis, once again, is actually maybe taking up lactate, and we can actually create glucose. And then lipid mobilization as well, so we could utilize that, the fat. Okay. So the biggest thing in regards to hormones that affect cardiovascular system kind of during exercise, definitely T4, T3. We have that contractility of the heart. Epinephrine, norepinephrine, once again, increase kind of that overall skeletal muscle blood flow. Like I said, that vasodilation. We also will see kind of heart rate contractility similar to T4 and T3. Norepinephrine really is going to see that constriction, like I talked about before. So that can increase blood pressure overall, but once again, is helping to get that blood to the working tissue itself. Okay. We could also see kind of just the ADH and vasopressin. This is going to actually help with kind of blood pressure overall, but then also sparing some of the fluid. So controlling water excretion by the kidneys. Once again, seeing that kind of increase in blood pressure. So regulation of carbohydrate metabolism during exercise. So really we see kind of this adequate glucose during exercise. We're going to have kind of glucose released by the liver, by the muscles. Okay, so really the key hormones for this and actually helping to increase that circulating glucose is going to be that glucagon. Okay, glucagon being released from the pancreas is going to help with promoting that increase of circulating glucose, as you can see here. Epinephrine, norepinephrine, cortisol, all helping to increase the amount of glucose that's circulating in the blood. So we can utilize that as energy. Okay. One thing during exercise, we see insulin production actually go down. Okay, so we actually see, let me go to a different slide here. So during exercise, epinephrine, norepinephrine, growth hormone, cortisol, glucagon is all going to help with the overall circulating glucose. And because of that, insulin wants to have you store the glucose. We want to actually increase the circulating glucose to help with the amount of glucose we can uptake in the muscles. So because of that, we see insulin production actually go down during exercise, which is key to kind of sustain that exercise. Okay. So regulation of carbohydrate metabolism during exercise, circulating glucose during exercise, really affected by human growth hormone. So human growth hormone increases the free fatty acid mobilization. Also, we see kind of a decrease in cellular glucose uptake with that release of human growth hormone. It really kind of the overall kind of glucose being released from the liver really depends on, once again, that intensity and duration. That's one of the answers I would think you could say for almost all of these hormones. That's going to have a huge impact on how the amount of that hormone being released is all based off intensity and duration, how hard we're working and how long we're working. Okay. Fat metabolism, definitely going to be epinephrine, norepinephrine, cortisol, and once again, that human growth hormone is going to help and assist with that lipolysis so we can utilize that fat. That fast. I realized it said 5 hormones. That should be 4 hormones, so I don't know why I put 5 hormones there, but. And then lipolysis helping to break down, once again, through that, increasing that overall free fatty acids. When muscle recovery, testosterone, human growth hormone, insulin-like growth factor, prolactin, all key in regards to that muscle recovery and then building muscle. Key hormones in regards to, once again, the recovery aspect of that, but during resistance training, helping to assist with actually the hypertrophy and building up the muscles. Okay. Other hormones that'll assist with that, definitely cortisol, luteinizing hormone. Okay. Oops. Also, kind of just that fluid and electrolytes during exercise. So that antidiuretic hormone that we talked about, that vasopressin, definitely is going to promote kind of the overall water conservation. Okay, so we can have kind of that reabsorption through the kidneys. And then just aldosterone as well, kind of increase that absorption of sodium, helps with the overall electrolytes and save a lot of those electrolytes so we can continue with exercise. Few things in regards to kind of that exercise high. We have the endorphins, dopamine, serotonin, oxytocin that's all being released. When we talk about kind of this exercise high, these key hormones that are being released just make us feel better. I don't know if you've all had this before, but after exercise, just feeling great within that. That's definitely endorphins, help with the overall pain. Definitely dopamine, serotonin, making you feel much better. Oxytocin, just overall, making you feel much better. So when we talk about this exercise high or this feeling afterwards, almost a sense of calm sometimes after exercise, these are the hormones that are really kind of helping and assisting with that. Okay. This will be a question. I want you to look through this, but can exercise be a treatment for depression? It definitely can, due to those hormones we just talked about. So I'd like you to look through. I definitely did not talk through every single thing that was in this PowerPoint. Please, please, please look through all of this PowerPoint and some of the key questions within the PowerPoint or some of the discussion points that I have in this PowerPoint. I would like you to be responsible for knowing that. But yes, it was great to talk with you. Talk at you, talk on this video, and then I will see you next week. All right, bye.